Okay, this set of notes will cover, again, it's a review of how to solve quadratic equations by factoring. So, when we're talking about factoring trinomials for today, we're going to stick to trinomials in the form x squared plus bx plus c. In other words, our lead coefficient, the number in front of x squared, will always be 1 for today. What we're going to end up looking for, in the basic gist of what we do to factor, is to look for a pair of integers that multiply to c and add to b. Okay, we're looking for two numbers that multiply to c and add to b. And we want whole numbers, positive or negative whole numbers. We want integers, not fractional pieces. Okay, so the mental math part of this, you don't necessarily need to show every time, but I'm going to show a few examples where I show the entire thought process. I don't expect you necessarily to show the entire thought process, but this is what you should be doing in your mind. Okay. So what you should be doing is looking for a pair of numbers that multiply to c, which you'll notice is 20. There are only so many pairs of numbers that multiply to equal 20. There's 1 and 20, negative 1 and negative 20, 2 and 10, negative 2 and negative 10, 4 and 5, which would be negative 4 and negative 5. These are the only 6 pairs of integers that multiply to equal 20. What we do then is we go through in our head and we add up the sums of those factors. And when we do that, what we discover is that in fact there's only one pair of numbers that multiplies to 20 and adds to positive 9. That's what we're looking for there, is our 9. That would be this row, meaning the numbers we are looking for are 4 and 5. So this trinomial would factor into two binomials with x as a first term, 4, positive 4, so plus 4 is one of those numbers, and positive 5, so plus 5. And that is how we factor that trinomial. Let's do another one. Here we're looking for two numbers that multiply to 12 and add to negative 8. So numbers that multiply to 12, we have 1 and 12, which would mean negative 1 and negative 12. 2 and 6, again, they could both be negative. 3 and 4, again, they could both be negative. Add up the rows in your head. Okay, again, we should not really need to spend, I missed a negative sign there. We shouldn't necessarily need to show this every time. If you do, that's fine. There's nothing wrong with showing your work. But at this point, we should be relatively comfortable. All we need to do is go in and find the pair of numbers that add up to negative 8. That would be negative 2 and negative 6. So this factors into x minus 2 and x minus 6. Couple more quick examples here. So again, here we're looking for factors that multiply to negative 15 and add to positive 2. When we're trying to get a negative number and we multiply, one of our two numbers is negative. So that could be negative 1 and 15 or 1 and negative 15. It could be negative 3 and 5 or 3 and negative 5. Those are the only four options because there are no other pairs of integers that multiply to equal negative 15. Once again, we notice that only one of those rows, negative 3 and positive 5, add up to positive 2. So that would factor into an x minus 3 and an x plus 5. Common question is, does it matter which of those two binomials I write first? No, you could put the x plus 5 first and it would still be correct. So x plus 5 and x minus 3 are the two factors we need, and it doesn't matter which order we write them in. One more example, factors of negative 18 that add to negative 7. So again, if we want a negative pairing, the negative 1 and 18, 1 and negative 18. Negative 2 and 9, 2 and negative 9. Negative 3 and 6, 3 and negative 6. Those are the only options. So in our head, we should think through these, and we should think to ourselves, well, which one of those adds up to negative 7? And again, we should realize that only one of them does, positive 2 and negative 9. So that would be x plus 2 and x minus 9. So then in class we went through some examples, and again I'm going to go through these relatively quickly. Again, we're looking for two numbers that multiply to positive 24 and add to 14. That would be 2 and 12. Okay. In B, we're looking for two numbers that multiply to 54 and add to negative 15. That would be negative 9 and negative 6 are the numbers that multiply to 54 and add to negative 15. For the numbers that multiply to negative 21 and add to positive 4, that would be positive 7 and negative 3. So n plus 7 and n minus 3. On letter D, two numbers that multiply to negative 30 and add to negative 7 would be negative 10 and positive 3. On letter E, we need two numbers that multiply to negative 48 and add to 8. That would be positive 12 and negative 4. Okay, this should be how quick we are in honors geometry at how quickly we can come up with these pairs. So if you're not there, you need to probably work on this skill. One thing you could do is go to Delta Math, which you should already be registered for, and there should be in there, in Algebra 1, the Algebra 1 list, a skill where you could practice factoring trinomials where a is equal to 1. Anyway, on letter F, we're looking for a pair of numbers that multiplies to negative 72 and adds to negative 1, because remember there is a 1 in front of that x. That would be negative 9 and positive 8. Now when we get down to these last two, you'll notice that they are not written in descending order. So the first thing you should do is rewrite them so they are in descending order of their variable. So 44 plus 15h plus h squared should be rewritten as h squared plus 15h plus 44, so that the exponent on the h goes down each time. We're looking for a pair of numbers that multiply to 44 and add to 15. That would be 11 and 4. Finally, on the last one, again, rewrite it in descending order, which would give us x squared minus 10x minus 24. Then find the pair of numbers that multiplies to negative 24 and adds to negative 10. That would be negative 12 and positive 2. All right, so that's how we factor. Now, once we get the factoring part down, the next step is to figure out how to solve. And that is using what is called the zero product property. The zero product property states that if we have two or more real numbers, a and b, and it could include c, d, e, as many as we need it to include, if we're multiplying real numbers together and we're getting a result of 0, so if a times b is equal to 0, then one of those numbers, either a or b, must equal 0. You can't multiply non-zero numbers and get 0. So there must be one of those two numbers has to be 0. Okay, so here's what we do with this. Once we get these things factored, we're going to have something like a pair of binomials being multiplied together to equal 0. Well, that is essentially a times b equals 0. So the zero product property says that one of those two things has to equal 0. And then we just solve those equations. So on the first one, we would add 2 to each side, and that would give us the solution x equals 2. On the second one, we would add 1 to each side, which would give us 4x equals 1, and then we would divide by 4 to get 1/4. Okay? Same idea on the others. We would set each term equal to 0, and then we would divide. So we'd get 0 and 3. Add here. Okay? We're going to pause the video here, and we will do an additional video later to finish the notes from this point. Thank you for your time.